Okay.
All right, guys. Today we're going to be going over electronics.
I love it, man.
All right. So, Ron, you don't have to keep notes like that. So you could just watch us back later.
Yo, appreciate that, bro.
No problem. And if you just remind me, because I'm just not that mindful, I forget. Okay.
Got you.
So, okay. Where were we up to?
We back up to the
Phase
code.
monitor. Okay.
Mm-hmm.
A phase monitor is important. This is what she looks like. Typically, she's going to look like something like this. Something like that, or
I have an ICM board written on my notes right here, but I never knew it had anything to do with.
remember,
Mm.
ICM is a brand. It could be a lot of different shit.
Yeah.
Okay.
Okay. You see this one right here, the black one, the ICM board?
Yeah.
That's a typical one that I see in the field. I see this one often as a phase monitor, the one that I got highlighted. You'll see there's a whole shitload of them that they use commonly. This one is this one's a common one too. Okay. All a phase monitor is, and Ryan, this applies to you, brother, when you're doing electrical,
Yeah.
is that when the three legs are coming in, remember, we're dealing with three phase. Okay.
Mhm.
If so remember, three phase 208. So you're talking about 120, 120, 120, right? 120 on each leg. If one of my 120s goes too low, it goes to like 90 degree at 90, let's say it goes to 90 volts. For whatever reason, Con Edison is going to shut the unit down immediately so your compressor doesn't get damaged.
Mm-hmm.
Oh, okay.
Okay? Why?
Protect the compressor from
burning out.
the compressor windings, yeah, from burnout.
Ah, my brother. How? Talk to me. Build. Don't stop now.
So the compressor windings itself is insulated. So if it gets too hot, then you're gonna actually have a burnout or shortage on the windings because the insulation basically the windings get too so hot that the insulation basically start to overheat and it diminishes, and then your windings you will have open winding on the compressor, and once that happens, your compressor is practically dead on one of the windings.
So peep this. You fellas see this?
You
This
have
is
a
the
shortage there.
winding from a compressor.
Yo, I think I got one of those joints in my bag. I took I don't know. I
Yo,
was
you
just
know what
standing
Ron is
around.
doing? It's gonna catch up to you later. He's one of those that like he doesn't like throwing shit out. He'll keep it in the van. He'll keep it in the car. Keep it in the car. And then
Mm.
over time, you're gonna have so much shit in there, bro. You know,
Yeah.
unless you're planning on using it for road rage and throwing it at people, you're just collecting garbage.
I love the way you said that, man, because
Yo,
sometimes, man, yeah.
you'll be careful. That should get you, you know. So,
Of course, of course, of course.
mind you, we're recording.
Mm-hmm.
Oh yeah,
That's
I
why we
forgot.
can't record shit. Okay. So, but when you get access to like a good dumpster, use them, brother, because otherwise you're gonna have too much. You're just gonna have too much in the vehicle. What are you gonna do with this?
I don't
Nothing.
know, man. I had to
Unless you
see what
plan
was
on
inside the
building.
motor. I needed to see what was inside of it.
Though I used
I
to be
needed
just like that. I used to be.
to... Yo, the tech had me just waiting around. I already know that we already did the job when we
Yo,
was
wait. How
burning
do you check
time.
the rotor? What do you do?
Say that again.
How do you check the? You know what you're supposed to do that, right? What you're supposed to be checking. This is
We
young
was waiting
blood.
around.
Okay.
Yeah, man.
All right. So you see this winding over here, right?
Yeah.
And if you look inside, you see how you got those little plastic spacers. Okay. So inside of that, you got a magnetic field. Okay. So remember opposites Amari, how's it go?
No, the opposite pole
They
repels.
attract
Right. Yeah.
unlike alike
Repel.
repels. Amari, am I saying that right, God?
No, you're right. So
Yeah.
if they lack the
Unlike attract, unlike repel,
repel.
right? So what ends up happening is when you get a magnetic field inside, I'm sorry, 1 second.
You must be busy. Sorry, I'll head out. What was that first name again?
Okay, so what do you call it? Over here, when it creates the magnetic field, it's going to cause that spinning, right? But across this whole thing, the winding, you got a little plastic, cheap plastic. Look at this, all this cheap plastic that they're using to hold it together.
Yeah.
Okay. If this overheats, there's too much amperage. It's gonna melt. And what do you think that's gonna happen? Anybody, you got long hair. So what happens if your braids start coming out? Your twists start coming out?
I gotta redo them.
It's gonna go bing, right? And so it's the same thing with this,
I like that.
right? When I would tie my hair back, right, and when I had hair once upon a time, right? When my hair would start like just being everywhere, right? My hair used to be like, I gotta show you my hair. My hair used to look like Buster, right? It'd be everywhere. It's gonna start touching the metal casing. What do you get if one of these windings touch the metal casing?
Short to ground.
Short to ground, right? Because there's electricity in here. If that electricity touches metal, yo, you in trouble. Somebody touches that, you get electrocuted.
Sir.
The motor?
Hell
The
yeah.
casing.
The casing specifically, okay.
Yeah, because the electrical
Whatever metal it's touching. Right? So that's why you have circuit breakers. So when it touches the side, it's going blah. So if you ever turn on a unit and it keeps blowing the breaker, don't turn around and keep going back and swapping and turning it on. More than likely, you got a compressor short to ground or fan short to ground. If it keeps blowing the breaker, start checking your components. Okay, for short to ground. Usually, the way I was taught by an older Trinidadian brother, the Mr. Alfred, my main teacher, right? He literally watched me. He sat there. I turned on the power, and it popped. It turned off. He just sat down and he said, "Today you're going to learn." He talked mad slow.
Yeah, this motherfucker not playing. I like that, man.
Yo, he an old black man, bro. I'm talking about he's like in his late 70s. He was too old to teach me. He was done. He had no patience left. But for me, he was just like one last guy I'm gonna teach. He was like Uncle Ron with you, Kenny, right?
Yeah.
Uncle Ron. He's
Yeah.
like, you're the last one I'm teaching.
Yeah. Basically, that's what he did.
He watched me blow that breaker like 15 times.
before
he didn't say nothing. He didn't say nothing, right?
He just watch you work.
And then after a while, he's just like, when are you going to learn?
Yeah, that was funny.
He's just
like that.
How many times do you have to make the same mistake?
Yes.
Yo,
that's
crazy. That's funny as hell.
And at that point, I was like, what? I'm so frustrated. Oh, Kenny, you think you got a short like fuse? Bro, I was acting out.
So,
I'm young. I'm mad energetic.
You never yelled at him though.
Huh?
You never raised your voice at him though.
No, what? Nah, that's big bro. Never would I raise my voice. I wouldn't even raise my eye. It's like talking to my father.
Right.
I raised getting out. Man, listen, when we were growing up, we got our ass whooped. Try to talk back to your parents. I grew up in the 80s where ACS would be like, did you beat them? Did you try that? You know? What you mean? So man, Mr. Alfred, I was kind of like, bro, what? And he was kind of like, did you check your compressor? You know, open winding. Okay. What happens is if you don't have enough power, it's going to continue to try to work, but now it requires extra work from that 108 versus 120 versus 120, that 80 volts. It's still going to try to spin that motor, but it requires more energy, more work. So it's going to cause a lot of heat. That heat is going to melt this windings. So instead of that happening and blowing a compressor, the phase monitor shuts off the unit. Okay? So when you get to a unit, if you got a phase monitor, you know, yo, Corey, what you smoking, bro?
Well,
Are you soldering? Yeah, yo, let me see that shit.
And this is all what the ICP is for.
The
Yeah.
IC.
Yo, look at this kid. Yo, I'm telling you, remember I was telling you, Tony, he's different.
I mean, I know.
He's
I
different.
told you, me and him chopped it up already, so I know
Yo,
how
he's
Corey.
fixing a board right now.
yeah,
Yo, Corey, if that's what you doing?
Who's Corey? Who's Corey again?
Corey's right here. 1 second.
Trying to find this guy.
There you go.
Is he a wizard?
Bro, that's a
Nah, I'm just taking the components off because
a lot.
I use them.
This guy.
okay.
Remember. Hey,
Yeah, I'm just gonna take some relays and what are you taking off?
Just resistors.
Why?
I just wanted to,
Teach you.
because you know how the H teacher was telling us to discharge capacitors with resistors.
Right.
I just want to have
this
some.
Johnson.
Oh, so you
Okay.
can check the capacitors on the heat pumps.
On heat pumps, yeah, on board and heat pumps, yeah.
Okay.
Yo, but if you're using like once you I showed you how just to use a screwdriver just to like
Oh yeah, I was just thinking of that.
The man
But
want to
continue.
do it. The man want to do it the right way, the professional way, with the resistors. You know what I'm saying? This is a
Oh,
technical
that's the
brother right
professional
here.
way.
This is a
That is the
technical
professional
brother.
way.
You know what I'm saying?
Corey,
You ever watch
Corey.
Undercover? You ever watch Undercover Brother?
no.
Right?
Oh,
And
Corey.
you got
Okay.
Smart Brother. This is Smart Brother in Undercover
No.
Brother.
Yo, you know what he reminds me? You ever seen that Jim Carrey movie?
Which one?
Me, myself, and Irene.
Yeah.
He's like this dumbass white guy, and he's got like 3 black kids.
Yeah, 3 genius adoptive kids.
Yo,
Corey one of them. Corey one of them.
Corey, bro.
Nice.
Corey's one of them.
It's like,
Yo,
yo,
Corey,
the funny shit is, they be like,
Yo, Corey, peace to the God, man. What up, bro?
Peace. What's up, bro?
What up?
yo,
What up, man? For
you
sure.
reminds me of that, like, yo, he mad smart. But
Yeah.
you see some dumb shit to him, you take a 2x40 your head.
Yeah, bro. You know what I'm saying? That's what's up. Cause the 3 adoptive kids, they hood, but they geniuses, bro. Like, yo, they got like they even got like Mensa, what you call it? Like they're part of Mensa and shit. You know what I'm saying?
I'm telling you, bro.
Shit is real, bro.
Oh man. Okay. So now you understand what the phase monitor is, though, right?
Yes.
Okay. So Ryan, anytime you put any kind of major electrical component, anything fancy in your home, make sure you got a phase monitor there,
Okay.
right? So a phase monitor is going to make sure that none of your legs is being lost, right? So I don't know, you're putting a fancy TV, you're putting a fancy computer, anything that you're going to be putting, you can put a phase monitor before it. Okay? So, just in case you get a surge or you get any kind of irregularity, it'll catch it and shut down all the components.
Yo,
Okay?
that's crazy being that you brought that up because I remember looking at some of the rack systems inside the boards itself. They had these phase monitors on each of these legs.
Yes, sir.
And I'm only able to connect the dots because we having this conversation. That's really
Right.
it. You know what I'm saying
So
so
those rack systems are ahead. You heard?
say that again.
Those rack systems are ahead. It's
Man,
almost like the guys who were doing the rack systems, they're kind of they're paving the way for the rest of HVAC. And the only reason I say that is I remember working with the rack system for SCT, brother. But the two Irish brothers who originally made the SCT, not the Mexican guy that owns it now. Okay? There used to be an
Okay.
Irish guy. Brandon McKay. Okay?
Mhm.
But yo, he's a nasty motherfucker, bro. Working for him. Yo, he's like 6'4", like fucking 250, 260 pounds, but all muscle. And
Oh shit.
the way he would yell at you, yo, he'd get me nervous. So I had to leave, man. You
He
know?
said I had to leave. He
I
said
had to
I had to
leave, man,
leave.
before I catch a case, bro. Like when
Yo, I see
somebody
what
that
you mean.
big and they're yelling at you, they get you nervous, man.
Yo, I'm not blaming you, bro. I'm not blaming you. I even like the way I that made me feel like I wasn't bugging, cause even with this company, bro, like
Right.
I told you Cambridge is offering $37 for the supervisor HVAC working position. I
Right.
don't even think I'm ready for that position, and even if they tell me, I don't know. I don't know what to say
Just
when they
take the
call me.
job temporarily until you could get into the UA. You got to get into the union.
This place is local 25, the one that's calling the one that is I think I'm good. They're gonna call me sometime next week. As every company in Boston has been calling me. That's funny.
Okay. Matter of fact, I'm gonna
We discussed about you putting in
magnetic.
everything at your pocket with your invention.
One second. My brother Magnetic is up there.
Bring 100 phones by then. Wow, man, I never made.
If I was you, Ron, I would take the job. I would take the job because you'd be surprised. You might go in there, you might find out there's the dudes in there that's not as nice as how you think they are.
That's crazy. And I'm with it because right now where I'm at, bro, they got me just doing ducks. I told the dude, I said, yo, I'm a service technician. He's like, yo,
Yeah.
bro, I don't want you to feel like you're stuck. You feel me? Just hanging up hangers. You feel me? For the ducks and shit like that.
Listen, but you still got to do it. So
Yeah, I did it. I did it. I did it. I did it.
right.
Yes, sir, I did it. Yes, sir, I did it.
Listen, it's
100%.
all HVAC, right? One second.
Yeah, 100%.
Yo, Magnetic,
100%.
is that you, God? One second, all right?
Yes, sir.
Sorry,
I did that shit.
Yo, peace.
Did it. Yeah, man, I did that shit, man. I hung them ducks up. He's cool. I like the guy. You know what I'm saying? He provided housing.
Yo, Magnetic, is that you,
job.
God?
Yeah.
It is I. Peace to the God. What's going on?
Yo, peace. Yo, Magnetic, look right above you. There's a brother named Ron. He moved
Peace,
to your
Ron.
area.
Is he?
Oh, salute.
Where
Yo.
you from?
Right now I'm in Brockton. I'm in Brockton, Massachusetts.
I'm in Nashua, New Hampshire. We're about a good 22, like about a good hour away from each other. I'm in the store buying HVAC tools right now as we speak, Raja.
Okay. That's lovely.
Yo,
Yo, my man
Almighty,
Roger.
listen, he's from now. Why? He just moved up there,
Oh,
right?
did he?
So if you could, he landed. He got a little gig on the plantation, but he needs something proper. You know.
Right.
So
Right now, I'm working for a temp agency. They're doing me pretty good though. They pay me good. That's why I stay with them. I can see, if anything, Raja, make sure you get him my phone number. And then tomorrow I'll start the process of helping him get in where I'm at. Because not for nothing, it's a temp agency. They pay me good, so I'm not complaining.
okay,
Mm.
all
And
right,
his name is Ronnie. His name is Ronnie.
My name
Magnetic.
is Allah Magnetic. That's just how Zoom signed me in. Yeah, my name is
Okay.
Allah Magnetic.
That's his
Yeah,
own
That's Allah.
government, bro.
Magnetic. Shalom. I mean, yeah.
Yo, Magnetic, this is being recorded. You heard?
yes, understood. Understood.
Okay.
I'm over here. Damn, where the snips at?
Yo, Magnetic, you know Amari, right? Amari, say peace.
Peace, Maury.
Amari's in here too.
Peace.
All right, here we go.
Okay. All right, so we're going
Yo,
back to class. Yo, Magnetic, stay tuned, man. Stay in the class.
I'm trying to stay in the class.
That's peace, girl. Okay.
Damn, I don't like these ones. They got new snips, right? I'm up at Lowe's, and this is what they have to offer me. I think I'm gonna go to Home Depot before I even play around like that.
Let me see the
Yeah.
snips. Now, what's wrong
I
with
think
them?
Lowe's is really good for Klein tools, but I don't think
Yo, those are
Milwaukee.
dope. What's wrong with that, Magnetic?
I like Midwest. I like Midwest or the other one there. What's the name brand there? Damn, I
Yo,
can't think of it.
Klein is what's up too.
Nah, I mean Milwaukee sells some good ones in what you call it, the wall and
How much tin you got to cut?
I'm not sure. I'm just bringing it to the job tomorrow because I need more tools anyway. Um, Hold up for 2 seconds. Give me 2 seconds and let me
Why don't
think
you get
this
the
up.
cutter for your impact driver? If they
I
carry
don't like
parts, they
that.
should have that.
I
they
had
don't
that.
have
I had that. I don't like that too well. Hold on for 2 seconds. Let me just hold on. Let me think this out.
All right. So
Uh,
we're gonna go back to building. All right. So I'm gonna put you on
cool.
mute. Whenever you're ready, just unmute yourself. Okay?
Sure. Peace.
Phase. All right. So that's the phase monitor. So if you got a brownout and you're getting 1 second. I'm gonna narrow this down a little bit and move this over. Okay. So that was the signals on the board. Okay. Now, number 3, it's saying the water coil freeze protection temperature selection. Okay. R30,
Mhm.
R24. So what do you do with that?
It's for free stat 1 and 2, right?
Yeah. No, but you see where it says 3 water
Mm-hmm.
coil? It lets
Yeah.
you pick the temperature?
Water coil.
It might be a dip switch or something over there, right? And then it says 4, which is the air coil freeze protection selector, which is
Might
not
be a might be a flow switch.
a what?
Flow switch.
Maybe, but on the board, there should be some kind of switch or something there, right? I'm not sure because it's saying that it's letting you what
Water coil.
it says selection.
What number you talking about?
Number 3 and 4.
Could it be the water coming into the water cool condenser, or if we have, or they're using it
Oh,
could be the water
no, I
coil,
get it.
the water
If
coil.
you wanted to bypass that, you could just put a jumper across it. So you remember how Corey was cutting out those resistors,
Yeah,
right? It's the same thing. You have something over there right there. You would put a jumper across them if you needed to bypass them ever. Okay? Make sense?
gotcha.
Right here from this line to this line, this line to this line. 1 second. Okay. All right. All right. So what's 6, 7, 8? Water freeze connection. You got 6. Okay. So this is where all the wires are going to be going, right? So if your water coil freeze connection is there, 6, it's going to be the output, and this one's going to be the input. One of these is going to be the output. That's going to be the input. So let's say your water coil freeze connection, Ron, you wanted to see if you wanted to bypass that, how would you bypass that?
The water freeze connection.
Yeah.
Where we at right now as far
So,
as the wiring.
so look at number 6.
Okay.
Right. So let's say One is the output and one is the input, right? Those wires. You see where it says 6 has 2 wires, 2 arrows?
Yes.
Okay.
Yes.
If I cut those 2 wires, if it's got 2 wires, right?
Mm-hmm.
One going into one terminal, one going to the other terminal, right?
Mm-hmm.
If I cut the back ends and tie them together, what would happen?
You make a jumper.
Yeah, it's gonna jump. Yeah.
That's it. So if you want to test if that's what your problem is, you could always jump these 2,
Oh, jump these 2. Okay. Okay.
right?
I got some
Temporarily
pre-made
overnight.
jumpers.
Okay.
Okay.
So, and again, number 7 you could jump, which would be the air coil freeze connection if you needed to jump them. Okay. Because one's an output, one's an input. Okay.
Okay. And hold on. The input and the output on number 6. So I have 2 ideas. I was thinking if the input was was on the left side and then the output was on the right side, or is it on one
It
of
don't
those?
matter. It don't
It
matter.
don't matter.
Because when we tie it together, whichever direction it's flowing, it's still going to be together now.
Okay.
Right? So the reason
Yes,
why I'm
sir.
teaching you that, never jump out of safety for long term. But if just for troubleshooting purposes, you could just jump it out in the immediate, then you go get the part you need, and then you change it out. Okay?
Okay.
In cooling, you might jump out
Sure.
some things. In heating, you never jump out anything and leave the room.
Mm,
Never jump out anything in heating and leave that room under any situation or circumstance. You could burn that building down. Okay.
okay. Oh,
And brother,
okay.
even with just bypassing safeties, testing, I've almost burnt down like units. Okay. So be very careful.
Mhm.
So, for example, my inducer draft motor is not blowing. Okay. And I jump it out. Or I have a hole in my heat exchanger. So, I'm not getting the I'm getting issues with the pressure switch. I jump out the pressure switch. I got a flame flowing back through my heat exchanger, shooting the flame back at me. Okay.
Well,
I've seen all kinds, so be careful when you're playing with
the
safety.
rollout. You
Yeah.
jump on the rollout. Yeah. Yo, that's what Uncle
So
Ronnie did. On that unit with he
Bro,
jumped out.
look
He
how hairy
jumped
my
out.
eyebrows are, my beard is. Imagine a
What?
flame coming this.
Yeah, that's crazy.
What happened to Uncle Ron? No, wait,
Yeah,
we're recorded. We're
he
recorded.
jumped out stage. He jumped
Nah,
out
no, no,
stage
no, no. We
2.
recorded. Leave it. Yeah.
He
But
jumped
I
out
know what
stage
you
2.
mean. All right.
He,
So, but you guys got a good idea of the board, right? And
yeah.
if you needed more information on the board, look, it's all right there. Look, the UPM dip switches, how everything's supposed to be. Okay. If there's a low pressure bypass timer, brown surge protector, where are my safeties? It's all right there. Okay. So, you know, again, I'm not in contact. I'm on a boat somewhere in the middle Pacific, and you guys are trying to reach out to me, and you can't reach out. Use each other. But remember, if you just find the manual, everything is there. Oh, look at this.
okay.
The thermostat
Yo,
to the board.
when I was in the because all right, so with the new company I'm at right now,
Right.
they were saying they were gonna put me with the line set guys, whatever the case may be. So they show so I took it upon myself to just stop what I'm doing and just go question the guy. You get me? Just go see what he's thinking, and I'm just like, because they're pressing a lot of these connections, which
Right.
I've never seen, especially in New York, and stuff like that. But long story short, I took a picture of the model and serial number of those units. You get me? And I just thought about it. I could just go start looking up and doing information on it myself.
Word.
and this and this whole class gave me the whole idea of doing it. You know what I'm saying? You were the pillar to even have me thinking like that. I took a picture. I wasn't going to even do anything with it. I was just getting ready just in case I
It
even
doesn't
start to
matter
use
where
it.
the interest gets
But
sparked from, right? But look, it's what you do with it now, right?
100%, I like that. Yeah.
Okay,
See?
so
Yeah.
matter of fact, let's go through this real quick, and we still got another hour of class. Let's look, if you can find the model and serial number, let's look it up.
Yo, let's do this.
So
I
look,
have the picture.
all right,
I'll
Mira,
put it
but
in
look,
chat.
for now, first, let's go through this real quick.
Okay.
UPM sequence of operation. It's literally telling you, okay, is there a call for cooling? Why one on? The power switches, sensor status check. What's happening? Look, and it's taking you step by step by step to troubleshoot. Okay. Now it's talking about water quality problems. So now I'm
Okay.
going to get into how this unit works. Okay.
Oh,
I like this picture, so I'm gonna steal this picture.
What's testing the water? Okay.
Yeah.
That's crazy.
Corey, how do I take a screenshot of this picture?
You have an Android?
It's a Dell laptop.
Oh man.
It should say like capture
Over here.
or
PC screen only. Or do I have to press Control F8?
it should be able to highlight it, turn blue.
All right, whatever. Okay. So look at this picture real quick. Okay. Now, that, and then let's look at
what's your number again?
mine or whose?
Where you get that number from?
Okay. You guys see this?
Mhm.
Yes,
Okay.
sir.
Now, this is your cooling. I mean, this is your heating heat pump, right? Let's go into cooling, actually. Make it easier because you guys are more familiar with the cooling side.
Mm.
All right. So this is a heat pump with the reversing valve. Okay. Now,
Okay.
there's something called a water source heat pump, WSHP. Very common in the field. What that means is your evaporator coil is still going to be air cooled. Okay. It's
Right.
still dealing with air. But your compressor, your condenser coil is going to be water. Does that make sense?
I'm
Okay.
following you.
Okay. So why would I do this? I got a cooling tower. You're at a mall. You're working, let's say you're at Palisades Mall, okay? Or Roosevelt Field Mall.
Okay.
Instead of having 1,000 condensers everywhere on the roof,
Mm.
they put a cooling tower.
Okay.
And they'll
That's
supply
understood.
all the units inside Roosevelt Field Mall with condenser water.
Mm.
Okay? Is condenser water and chilled water the same thing, my brothers?
Say that again.
No.
Is condenser water and chilled water same thing?
No.
No. Chilled water comes from a chiller. Condenser
Mm.
water comes from a cooling tower.
Correct.
Mm.
Okay? What is a normal temperature for cooling tower water? Guesstimately.
About 75 to
85.
80
Word.
degrees.
75, 85, 90, somewhere in that range. Okay? So anywhere from 70 to 90, I'm all right. 75 to 85, I'm golden. Okay. Now, that cold water is going to come back and we're going to run it through the outdoor coil. But instead of running it through the outdoor coil, it's going to look like this right here.
Mm-hmm.
That cold water is coming in, and now the refrigerant coming out of my compressor. If you see my compressor right here, okay, you're going to have the suction line come in, and then it's going to come out the discharge and go through the coil within the coil. Yo, my
Mm-hmm.
brothers, we have a special guest tonight. Yo, Frankie.
Hey, what's going on, man?
Face, brother. Yo, show your pretty face, man.
Oh, I really can't right now. The hair's crazy right now.
That's all good, unless you're in the toilet.
Nah, nah, nah.
All right. So my brother's Frankie. Matter of fact, Oteni Corey. Corey.
Yeah.
Corey. This is Frankie. This used to be Jeff's old partner at Fresh Meadows.
Oh, it's
Oh,
nice to meet you guys.
Yeah.
same
Hey,
here, bro.
sure.
Peace.
So Frankie, you got a whole lineup of different type of brothers in here. You got some A-side steam fitters with grays in their hair, so they've been A-side for a long time. You got a custodian engineer in here. You got Keith in here who used to run like entire facilities. You got Ron who's trying to get his weight up.
That's a fact.
You got me,
Word up.
OT, and Corey trying to get our life together. You got Amari, who's a family, who's coming into the industry. And you got Magnetic, who's up in Boston or somewhere, New Hampshire or some shit. Um, just furthering himself. So you got a whole bunch of guys in here tonight.
It's a pleasure to meet you guys. I'm sorry I'm not showing the face right now.
So
It's cool, brother. It's cool. We don't always could show our face, you know what I'm saying? We want to record it on video anyway.
Oh, word, yeah, Frankie, be careful what you say. Everything's
Yeah,
recorded.
absolutely. I understand.
Yeah. And so I always ask everybody any open warrants before we start recording.
Yeah.
What do you call it? But Frankie, he's how old are you, Frankie? Like 30?
I'm 32.
Wow, this guy's a young man.
But
Yeah, 32.
his pops, to my understanding, and your uncle both are chiller guys, right?
Yeah, I got two of my cousins. My dad and my uncle are in the field 638.
Right. So he grew up in the business. It started young, worked his way up. He was B side for a long time, then he was A side, and then now he's local 30, I think, right?
Yes, that's correct.
Yeah,
This because still waiting on you. Don't forget me.
right. Um, I think Rashad, are you in here too?
Yeah, I'm gonna come get you. Just call me. Let me know.
Okay. I think
All right.
Rashad came out. 1 second. I'm sorry, my brothers. 1 second.
All right.
My bad. Okay. All right.
Don't worry
So
about it.
Ryan, Frankie, we're going through what a water source heat pump is tonight, right?
Okay.
So what we started from tonight, just to catch you up in our class, was I said, yo, Rod's not always gonna be here, right? So what do you do when you walk up to a unit and you don't even know what you're looking at, right? Which
Yeah.
happens. It's gonna happen. You're walking up to a dry cooler, you're walking up to, I don't know, an evaporative condenser, you're walking up to like all kinds of weird shit. There's a model number. Find it. We went through it. We found the manual together. We went through the nomenclature. We're going through the boards and how informative these manuals really are and how reading these manuals could save the day for you, you know?
Absolutely. And also, when it comes to that type of stuff, the nameplate is very, very important. And understanding if anything was retrofitted is the most important thing to understand.
So do you brothers understand what he means by retrofitted?
Is anybody made any changes to the compressor, the refrigerant, or anything like that?
Word.
Yes.
So let's say we have a R22 system, and they say, you know what? R22 nowadays, what do you call it? You know, R22
Like
is too
phased out or
expensive.
something.
It's
Yep,
phased
yep.
out. It's too expensive. So we're going to use 407. Okay. Or, they nowadays, what are they going to fit? What can we use for 410?
Um, retrofit for 410. Um,
I don't think there is, right?
no, there's
Or
not. At least not that I know of.
Not yet.
not yet. But whatever it may be, like that. So you got to be careful. It happens. It fucking like I've seen guys. You know where it happened? Oteni. It happened at fucking to Nick and them at that what do you call it in
What you call
Brooklyn?
Moore Street?
Where?
Moore Street?
Word at the Moore Street Market, right?
Hmm.
Where these guys changed out from R22 to 407. Now unless you marking up your unit, how are you gonna know what's in there?
Hmm.
Right? So he's right. When you read the nomenclature, you got to make sure that nothing's been retrofitted, right? Or, usually if guys have some decency, they'll write on the compressors itself 407, or they'll write it on the big, like somewhere on the unit in big
Right,
handwriting.
right.
So,
Hmm.
mm. Guys, this is one of the few times where this little brother right here, he's got more experience than me in the field. So I'm gonna let him take over wherever he wants to take over, Frankie.
Oh no, man, this is your class. I'm actually just excited to be here. I just want to hear you guys you know, just
Nah,
We build
yo,
continue, please.
we
hey, this
building
is
and learning. We're building and learning.
this is somebody
Yeah,
that
I
you
like
guys
it.
should know.
No, I really like it.
This is somebody you guys should know because he hustles. When I say he hustles, if you think I hustle, this kid hustles. I thought, he mad young, got himself into freaking into local 30, which is it's not easy, you know?
Yo, he remind me. He sound like I
Frankie.
don't know if it's the
No, no.
movie Boiler Room. I
Uh-huh.
don't know if you ever watch it with like an old
Nah,
movie
nah, I gotta look it up. No.
with Vin
Oh, the old
Diesel.
school movie.
Yeah,
Word.
yeah,
Word.
and
That's
what the
like
dude was
Brad
trying.
Pitt and all of them. Yeah,
Yeah,
back in the day.
he's trying to come up. He's not nah. You thinking about Fight Club, but is a movie with Vin
I remember
Diesel.
Boiler
Yeah,
Club. Boiler Room.
and
Yeah.
the young kid Frankie, he's trying to come up in the stock market biz. You know what I'm saying? And you sound just like the dude, bro. You just sound just like that young dude.
Yeah, that's funny.
All right. So, fellas, we were talking about a water source heat pump. Okay. So now you got that compressor here. Now you got the coil within a coil over here. What does that mean, a coil within a coil? So inside of this coil, you have another coil that you don't see. Okay. You're gonna have that water running through in one direction. You got the refrigerant flowing through in another direction. Okay. That condenser water. Remember, where's the condenser water come from, Ron?
The condenser water comes from the
Where's chilled water come from? Look at the
mm,
word. Chilled.
the chiller,
Word. And then the
and the
condenser
condenser
water.
water comes from the water tower.
Word. The cooling tower.
Yeah,
Okay.
the cooling tower, the
The
water
cooling
cooling
tower.
tower. Yep,
Okay.
got you. Appreciate
So
that.
what that condenser water is going to do is going to take the heat from that refrigerant. Okay. So if the heat dissipates to that condenser water, what's going to happen to my refrigerant?
Say that again.
Okay. So if I got my compressor discharging into this coil right here, okay,
Okay.
what's going to happen as it runs across the condenser water?
I think it should warm up the water as well too.
It's going to warm up the water, but more importantly, it's going to
Mm-hmm.
cool down the refrigerant.
Mhm.
Okay, it's
Right.
gonna cool down the fridge. Okay.
So,
Okay, because it's all right.
right. So, peep game, right? So, whereas over here we had, one second, where do we have that picture? Okay. So here, the discharge goes outside to a condenser coil and dissipates the heat, right? So you got the high pressure, high temperature vapor coming out the discharge line, okay? Goes in through my coil, and as it gives off the heat to the outside, remember hot goes to cold, okay? So as it gives off the heat, it's going to slowly start becoming what? High pressure, high temperature vapor becomes a high pressure, high temperature
Liquid.
liquid, right?
Liquid. Oh.
And the point where it starts transitioning is called what?
Saturation.
Saturation temperature, word.
Super-
Okay. So if I put my gauges on the unit, okay, and I'm reading my high side, what am I really reading? Am I reading what's happening over here in the discharge line? Am I reading what's happening here in the condenser line? What am I really reading on my gauges?
And the liquid refrigerant.
Are you whispering?
I mean, I don't want. I'm a part of the class, but I don't.
You're a grown-ass man. Come on, let me hear your voice, bro.
I want to give the other guys a chance to answer. You know what I'm saying? So I
Speak
don't.
up. It's all good. So, all right. So, what do we? When I put on my gauges, right? No, when you put on the gauges for us when we're on the job, what are we reading on the high side?
Reading the liquid refrigerant.
We're reading what temperature is. We're reading the saturation temperature,
Temperature, correct.
right? That's
Yeah.
the point where you're going to go from the vapor to liquid. Okay. Now it's not a perfect. It's not a. We going straight from liquid into dead ass vapor, or from. I mean, my bad. Going from high pressure vapor, it becomes a straight up liquid. That's where it starts changing, right?
Right.
And ideally, that's happening halfway through the coil,
Mm-hmm.
right?
Mm.
But if she's flooded, it could be happening somewhere down here, right?
Mm-hmm.
And how do we gauge where it's happening?
Whatever pressure you're getting on the actual gauges will tell you exactly
Well,
what
there's another point of information that we look to.
the saturation temperature on the gauge itself,
Or
the your subcooling.
word. Okay. So if I got really low subcooling, right? What does that mean?
If you have really low subcooling,
Yeah.
that means that the what you call it, the vapor it's vapor is saturating too quickly inside the condenser, So it's
Okay.
turning to vapor, it's turning to liquid too early in the condenser.
So okay, so
Mm.
you're saying why would that happen?
Is due to the fact that you what you call it, you have
Not
uh
enough.
no.
Word. Add on. Ron, you said it.
Not enough refrigerant.
Word. So peep game. If I have not enough refrigerant, right, coming out,
There's not going to be no force or power to push that through to change it to a liquid state.
not
That's the
necessarily
only
that. What Oteni said something on point. That shit is
Mm.
flashing off too quick. It's going from a vapor to a liquid mad soon, mad early, right?
Mm-hmm.
Okay. And so then when it comes through, your subcooling is going to be a lot, or it's going to be high or low.
Gonna be low.
No, actually, I lied to you.
Wait.
Yeah,
No,
I
it's not.
fucked up.
Wait, hold on. Let me check. Let me double check that.
If I got high subcooling, that means I got two high
Low,
subcooling,
low charge.
low charge. No. Wait, Frankie, jump in here for a second. If I got high of superheat, that means it's starving. Low subcooling means starving. If I got high subcooling, that means I got too much refrigerant. Word, right?
Okay, low subcooling.
Corey, jump in. Corey, Frankie, asking for a friend. All right. So
All
if
right,
if we got if we got too little subcooling,
low subcooling generally
low
indicates
subcooling,
Yeah, not
That
enough refrigerant in
that
the condenser.
means, yeah. So if I got too much vapor coming in here, too little vapor coming in here, she's
Mm-hmm.
gonna turn to liquid quick,
Correct.
right?
Yeah.
She's gonna turn to liquid quick, and then you're gonna give off too much heat, so
Mm-hmm.
you're gonna get a high subcooling. That means you had too much. Wait, high
Too much vapor.
subcooling.
Low,
Yeah.
you're supposed to have low subcooling. That's a low subcooling
Like that.
when you're it's low subcooling when you're under charge and it changes state too quickly.
Yeah. Yeah. See, high subcooling means there's too much refrigerant. Okay.
Correct.
And low subcooling means, okay, too little.
Not enough refrigerant. Under
Right.
charge.
I was right. Okay. I was right. I had a moment. My bad. Okay. So really what we're looking at is a saturation temperature where it's going to change.
Mm-hmm.
If I got low subcooling, right, that means I'm not giving off a lot of heat. I'm not losing a lot of heat after it changes state. Okay. So it's taking too long to change the state. Okay. So that's an indication of what do you call it? Undercharge.
Yes,
But the
sir.
bottom line, really why I'm doing this is instead of having this being air cooled, all we're doing is instead of running a fan across this, running this through water. You get that, Ron?
Yes.
So instead of this being air cooled, now you got it water cooled.
Mm. Instead of it being air cooled.
So the inside is still the same. You're gonna have air going across the evaporator coil, right? So
Yeah.
all of this stays the same. The inside part all stays the same. Okay. But it's a water source heat pump. So now you know you got the reversing valve.
Mm-hmm.
Okay. You still got the two expansion devices and the check valves and all of that. That all stays. Only thing that changes is you're going to have that tube within the tube here.
Mm.
Okay. And that water is going to be going to the cooling tower and coming back.
Mm.
Okay.
It's gonna
So,
be returned.
right. So now that it heats up the water, that warm water is going to go back to my cooling tower and it's going to give the heat off in the cooling tower and come back down cool. And then
Mm.
cool this down again. So let's see if we can find a water source heat pump refrigeration cycle. Okay.
Okay. Water source heat pump refrigeration cycle. Okay. That changes it now. Changes the lookout.
Yep. So all right, can you brother see this?
Mm. Look at the guy.
All right. So,
Oh, it's in reverse.
okay. So you got your cooling tower here. Okay.
Okay. Yeah.
Now you got this water being pumped into the cooling tower, which is being cooled. Okay. As it
Mm-hmm.
comes down, can everybody see this?
Yeah.
Uh-huh.
There's a big fan that's turning. Okay.
Wow.
So, and it's pulling the air across this coil and up. So as the water comes in from the top and the water drops down, as the water drops down, the air is coming in across and it's going to cool it.
Mm-hmm.
Okay. So now As it comes back down from the bottom, okay,
Mhm.
it's going to go into this heat exchanger.
Mm-hmm.
Sometimes they'll have a heat exchanger. Sometimes they'll have it'll go directly down here to its side.
Mm-hmm.
Okay.
Mm-hmm.
Oteni, where do we know Oteni Corey? Where do we have a heat exchanger like this? And which one of them counts to a cooling tower?
Where did I see that one?
Think of John Street. South Street Seaport.
Yeah, it's also Seaport, but I don't remember seeing that
So peep game.
external heat exchanger.
There's an external heat exchanger in that boiler room. Down there by the pumps in the basement,
All right, yes, that's true. Yeah,
there's a heat exchanger down there.
yeah,
Okay. It's an old, nasty heat exchanger, but it's there.
I
Okay.
remember it.
So what is this called when you add hot water into it?
This is
Heat
what's huh?
injection. Heat injection.
Uh-huh.
Okay. All right. So we'll talk about that in a second. So here's the loop. This right now is coming down through the heat exchanger and then coming back getting pumped up.
Mm-hmm.
Okay.
Mm-hmm.
Now down here you have another pump. So as this water comes in nice and cooled, okay, this heat exchanger, this water and this water never touches each other. You guys understand that?
Right.
Mm-hmm.
They're separate from one another. Okay.
Mm-hmm.
Same thing in here. The refrigerant and the water never physically touch each other. They're in two separate pipes.
Mm.
So if you got copper in between, what's going to happen? It's going to conduct the heat through the copper to the refrigerant, right?
Mm.
What would happen if the refrigerant and the water touched each other?
Acid, I would assume.
Mad problems.
Mm-hmm.
Problems blowing your compressor, all kinds of things that happen, right?
Mm-hmm.
So that's a no-go. Okay. 1 second. Where was the other one that I was looking at? Right there. Okay. Now, so it's going through the tower and coming through. It's coming up this way and going through.
Right,
So
that's the loop.
this heat exchanger. Now, this heat exchanger is going to take the heat coming from this loop. Okay?
Right.
So as this water is going to go down, okay, that's my suction side of my pump. That's my discharge. It goes down, comes down. Bang. What's this right here now?
That's another. That's the another heat exchanger, or the condenser.
It's another heat exchanger, right?
Yeah.
Right
Or
here.
the condenser water
Right.
coil.
But now, peep game though. The air is flowing this way. Okay. So
Mhm.
this right here, look where my compressor is going. The suction line goes into my compressor. You with me, Ron?
Yes, sir.
You see this coil? That's my evaporator coil.
Mm-hmm.
The suction line is going into my compressor.
Mm-hmm.
It comes out my discharge line.
The outlet.
And then it's going into this coil.
Mhm.
Okay.
Mm-hmm.
Now, this coil, as it comes in, it's coming in from the bottom. It's going to take the heat from the discharge line, go back up here. You following the arrows?
Yeah.
And it goes back through that heat exchanger.
Mm. Let's run through it again, please, if you don't mind.
Sure, absolutely. Okay. So, Bick, you with me? Everybody with me on this one?
Yeah.
Yo, Ed. You with it?
I'm here.
Okay. So you get how this whole thing works?
Yes.
All right, talk me through it then, brother.
Where you want me to start from?
Wherever you want to start from.
The beginning.
Start at the cooling tower.
Yeah.
All right, we got the cooling tower, right? We got the big fan on top, which is bringing the air through, right?
Okay.
It's taking the temperature from the water. The water's dropping down in the pan, right? It's
Mm-hmm.
okay. It's going. Now it's going. It looked like it's going to a heat exchanger,
Right.
Mm-hmm.
right? Which is the heat exchanger, right? To the
Yeah.
pump, but also as it goes to the heat exchanger, it's going to transfer heat from to
Mhm.
the other one.
So that
So
water
remember,
never touches that
so
line
this
as
right.
mm-hmm,
So in
as
this heat
Rafa was
exchanger,
saying.
Right,
this,
huh?
this bottom loop is gonna
Right,
create heat, right?
right,
The top loop is gonna take that heat from it then.
right, right,
Okay.
right. Then, yeah.
And then this one, so this is always gonna circulate up here only,
Oh, yeah.
right? And it's never gonna touch this. But what it's gonna do is gonna take the heat from it through the heat exchanger.
Right.
Okay. All right. So now talk to me about this bottom loop.
The bottom loop look like it's going through there. It look like it's going to a pump.
Uh-huh.
Pump is going down. Pump is going to the air handler. Look like,
Yep.
Mhm.
Yes, sir.
right. And then it's going to go across a coil, and the fan is going to blow it.
So what's happening? This is you got the regular refrigeration cycle happening here, right?
Right.
So you got air blown across, the hot air blown across.
Right.
So as the hot air blows across this evaporator coil, the evaporator coil is going to take that heat. Now it's going to come down through that suction line. Okay. It comes
Mm-hmm.
up that discharge line, high pressure, high temperature vapor, and it's going to go into this coil. Okay.
Right.
That coil is a condenser coil. The liquid. It's the what do you call it? The coil
Water
within the
cooler.
coil. Now
Mhm.
it's going to pick up the heat from the condenser, from the compressor, and now
Mhm.
it's
Right.
going to cool it down. Okay. So now this comes out my liquid line. Okay. Going to go through my metering device, and then it's going to go through my evaporator coil.
Right.
So just like here, just like just like the outdoor coil, rather than the outdoor coil, this time it's gonna be what do you call it? The
Water
coil within
cooler.
the coil. It's gonna
Yeah.
look like this. Okay. So in here, you got the condenser water flowing through it, and inside, and you're gonna have the refrigerant flowing on the outside of that.
Gotcha.
Okay, in another tube. So the water and the freon never touch each other though. Okay,
Right.
but it's gonna cool it off. It's just too much happening. So this makes it easier for me to switch back and forth, right? Okay. So that's that coil right there. And it comes back after here, it's going to go back up
Right.
through that heat exchanger. And the heat exchanger is going to pick up the heat. Whatever heat that it picked up from over here is going to get picked up in that heat exchanger and go
Mm-hmm.
out. Okay. Now I'm going to add something brand new. What's this boiler water doing inside my condensate water?
So it's there to maintain the actual water temperature.
You tell me. So you and Uncle Ron fixed the tower at the museum on John Street, the Seaport, before,
Mhm.
and that's got heat injection, right?
Mhm. Mhm.
When do they add the heat injection?
Oh, during low ambient.
Word. Okay. So now it's wintertime. Okay. Now you're not gonna have this water cooling tower running that much anymore, right?
Mhm.
Gotcha.
Yo, if it's December, January, February, you might freeze this water. You with me?
Yeah.
So what they'll do is they'll shut this valve off. No, actually, I lied.
No.
I lied. They're gonna turn this fan off.
Mm-hmm.
Okay. And what they might do is just have the makeup water here. Actually, no, this is gonna still be there.
For the top. You won't go over the top anymore. They'll close the valve, go for the water going over the top, and they
Right.
just use the sump water, the basin water.
The basin water, right? So,
Mm-hmm.
but then how would it get the makeup water from the bottom? How are they gonna
Because
make sure?
I guess that water is coming in cold, so it will actually that very cold water will mix with the heat exchanger with the injection water from the boiler.
Well, I think what they can do in that situation, because this tower is a little different, right? I
Mm-hmm.
don't know if I would run this tower year round. At Seaport, do you guys run the tower on Beekman year round, or you guys shut it off?
No, they shut the tower off, so the fan is off. The
Uh-huh.
pump is the pump. The
Uh-huh.
pump is only pumping the water down. No, the pump is off because the pump pumps the water over the top. So the pump
Okay.
is off, the fan is off, and basically what it's doing is that cold basin water is just basically being going down to that heat exchanger, and from there it is mixing with the actual water, the boiler water, to maintain the temperature.
Okay. So what they'll do is, because remember, in the wintertime, you're trying to take the heat. So in the wintertime, you're trying to take heat out of that coil. You're not trying to cool it anymore,
Mhm.
right? While it's in heat pump. Am I making sense?
I understand what you're saying, big bro. I don't know if
So
the other guy.
right. So do you guys understand that?
Nah,
So in
like,
the wintertime, right?
right.
Notice how this whole thing switches your outdoor coil and your indoor coil. So what's happening at the outdoor coil is you're sucking in the heat. Okay.
Mhm.
You're picking up the heat from outside. You're gonna now comes this way, and that's gonna be your suction line. Okay. You picked up the heat from outside. Now it's gonna compress and become high pressure, high temperature vapor and go in through the room. And it's gonna dissipate that heat. It's gonna cool down, go through this expansion device, become even cooler. So it could
Mhm.
be colder than outside and pick up heat again.
Right.
Right? So how am I picking up heat when it's 30 degrees outside?
It's still heating. It's still heating it.
Word, right? Because remember, it's not an absolute zero. So you got plenty of heat outside at 30 degrees. It's going to pick up that heat and now come back through my suction line, through my compressor, which is now going to compress it, make it a high pressure, high temperature
Mm.
freon, and then push it back through my indoor coil, which is now going to heat up the room.
Mm-hmm.
Right?
Reversing it. It's like reversing it, I'm guessing.
Yes.
Exactly. Who
Yes.
said that?
That's Ron.
Right. Yeah. When you say it was reversing it, that's why we call it the reversing valve.
Okay, I'm slowly catching on to it. It's very different for me.
It's all good, man. Take your time. Okay. This ain't your first class, ain't gonna be your last class. Right? Like
Gotcha.
it took me a long time to really understand what I was doing with this shit. Right?
Mhm.
So, okay. But you peep how this is picking up heat from here, right?
Mhm.
So here it's the same concept though.
The
Where are
the
we gonna
problem was is this blueprint, or it was a lot more complex than the other one. Like, it was hard for me to sort of grasp anything, but I understood where you were saying, um, you see where that pump is bringing in the water into the cooling water tower, and then now that bottom, I guess that bottom valve where the water's going up into
wait, so check
going
this.
up to the heat exchanger.
Right. So the other one was picking it up from outside the heat, right? But now
Yeah.
here it's adding the heat right from the boiler.
Okay.
But when you're thinking of boiler water, you're thinking like what, 100 something degrees, right?
120, 120, yeah.
Yeah. We're not talking about that much heat here now, right?
Mm-hmm.
So, Frankie, he actually works on these every day. Frankie, you there? Okay, he's not there. Okay. So, well, okay, let's see. Condensate water temp for heat pumps in winter should be what temp? The water loop for multiple water source heat pumps is typically maintained at operating temperature between 60 and 90 degrees, right? So you're thinking like the water should be coming back around 90 degrees. So this boiler is not shooting super hot water in here. It's pumping just enough hot water just so that when it comes back down through the condenser coil, okay,
Mm-hmm.
it's going to pick up enough heat to warm up that other coil. Okay, so it's going to bring that enough heat to go through the compressor, and the compressor is going to now go backwards and heat it up. So if it comes in at like, let's say 90 degrees, it's going to shoot it out at about 120 degrees. Make sense?
Yes.
Okay. And 1 second. Frankie, you there? Frankie. I'm gonna text him and see if I can get him back online. So all right. So now it comes back. Okay. Any questions with this right here? Any of this? So don't let this scare you. Okay. It's just going through multiple steps. This is called a water source heat pump. What is this called?
Water
Water safety pump.
source heat pump.
Water source heat pump. Okay. You got return air coming in just like a regular rooftop package unit or a regular air handler. Okay. Now it's going to get cooled or heated and go back down.
Yeah, sorry, I was muted for a while.
Mm.
I didn't know you unmuted me.
Yeah, it's all good, brother. I was trying to get your attention. You work with cooling towers more than I do. So in the winter time, in heat injection, what temperature is the condenser water usually?
It depends. It depends on what's the load in your building. So it's usually around, I want to say 85-ish.
So it
And
stays
I'm
pretty much
talking about a campus. Like in my campus, we run it around 85-ish.
85. Okay. So it's pretty much 85 all year.
Yeah.
Okay. I have another question for you. In a cooling tower, right? In the winter
Mhm.
time, in a
Yeah.
like I've seen different applications with the cooling towers. They turn off the fan, right? And
They turn
sometimes
it off, or I'm sorry to cut you off, but they
no, go
turn it
ahead.
off, or sometimes they reverse the fan so nothing doesn't freeze. So it depends. Again, if you run glycol through your, like through your water and
Right.
all of that comes into play. But that's more complex stuff. But usually, a lot of plants that I know of, they run their towers in reverse, or if they don't do that. They still run their pumps. They do still run the pumps because it does have to circulate. You can't just have water just sitting
Sitting
there
there. Hell no.
not doing anything.
It's gonna
So it
freeze.
does, because like for this print right here, so what it does is that pump is still on because it does have to circulate water.
Right.
So it's going through the heat exchanger, and you see your boiler.
Yep.
So it is picking up that water and still, circulating through the system. Excuse me.
We usually just call that heat injection.
Yeah, heat injection. Oh, okay.
Right. So, word. But sometimes they will have like a bypass over here, right? So instead of going back over the top, it will just sit in the
Yeah.
sump. And in the sump, they'll like I've seen them have like electric tracers or
Yeah,
heater.
they have the basin heater, the basin heater.
Basin heaters. Yeah.
Yeah, in addition to if they're gonna treat the water, you should have a certain degree of the glycol in there, right? Because man, that water freezes all the time.
Mm-hmm.
You know, so and we just had that. Remember, actually, Oteni, you weren't there, but when we went to John Street, Seaport, even the condensate drain line, the drain line coming from the tower,
Yeah, it was
that had
frozen.
frozen and it bursted, right? So we just wrote that up recently when we were there, you know? So in the wintertime, this tower is not going to be running fully. You're still going to have water going through it. Normally, Frankie, it's right. You're going to have a bypass here. Instead of going to the top, it's going to
Yeah.
go through the bottom and
Yeah, you would
stay
have
right
the
here, right? Because it's so cold outside that it doesn't need to trickle down and lose that heat,
Yes.
right? And remember, we're using this water now for heat, right?
Yeah, for heating the boilers. Yeah.
So when it comes through here, it's going to be picking up the condenser is actually becoming the evaporator coil, like over here,
Yep. Roles are in reverse. Yes.
right? So now it's picking up heat from out here,
Yep.
and then it's gonna go into so remember, through the reversing valve, it's now your discharge line. What was your discharge line over here? You see, this was your discharge line before, guys.
Yep.
Now it's going in reverse.
Yep.
Right.
Through that, what the fuck you call that? Through the reversing valve,
Reversing valve. Yes.
and then it's gonna go back in,
Yes.
and that's gonna be a suction line.
So for the
It's gonna-
guys, so what he's saying is, so the roles are reversed. So all of that cold air is being picked up and being sent to the compressor, right? Now, what the compressor does is it compresses. You guys ever, how do I explain it? You guys ever took a drill, right, and nailed something? Let's say you drilled into wood, right, and you saw how that wood smoked, how
Right.
it was the compression, right? So that and it was hot. So what the compressor does is it takes that gas and compresses it, makes it really hot and warm, and sends it through the building or your house. So roles are just reversed, and it's also taking the cold air from your house and then sending it out, in reverse, if that makes sense.
So remember, the compressor is compressing. So when you compress something, you're increasing the pressure. But what happens, fellas, when you increase pressure?
You can increase temperature.
Word. What happens if I decrease decrease pressure?
You decrease the temperature.
Word. So inside the compressor, right? The refrigerant's coming in. The purpose of this compressor is to do what? Compress. Increase the pressure, increase the temperature, right? So when this comes back in, it's coming back in lukewarm. But by the time it comes out, it's dead ass hot, right? It's going to go in here at what temperature? Let's say maybe 90 degrees. It's going to come out at $120, right? It's going to come out nice and hot. Go through the thing and then go through my coil and dissipate the heat. Ron, does this all make sense to you now or not yet?
Yeah, so what I was able to realize was for instance at the cooling tower, right? It's its own cycle where I see the pump where it's going in and it goes out and it goes in and it just stays right there, that water.
Word.
But also what the heat exchanger is right there. It's like this whole other cycle connected to the boiler.
Right.
And somehow that that water goes down to the like for instance when we're looking at the heating mode, it
The
goes
ear,
down.
the ear.
Yes. Oh, okay. Thank you. The air handler. It goes down into the air handler, and some and it's returning. It's like this suction that's going on, and then it gets compressed up as to you guys were saying into high pressure, and then the motor blows it out to the heat. And as far as me going into the it would be the same thing for the cooling mode just in reverse. Did I make was I off?
You know, you're making sense, Ron. So what we're doing is we're just moving water. That's all we're doing is moving water. It's not looking at all of this is overwhelming, but that's all it
Yeah.
is we're moving water and turning it either cold water or hot water into
Uh-huh.
coils. So, you know, it could go through the buildings.
So look, what he's saying is summertime. This cooling tower is only cooling the water.
Mm-hmm.
Okay?
Summertime is only cooling the water.
Cooling the water. And you have this fan running and this pump pushing the water all the way above and dropping it down so it can dissipate the heat.
Uh-huh.
The water comes in warm because of this heat exchanger,
Mm-hmm.
and it's gonna go ahead and come back down cool. Okay.
Mm-hmm.
However, in the wintertime, what we're gonna do is we still want this heat exchanger. Okay.
Mm-hmm.
What we're gonna do now is turn this fan off.
Mm-hmm.
And instead of shooting the water to the top, we're gonna shoot the water right into this area, this basin, right? Directly from instead of coming up here, there's going to be a bypass. It's going to go right to the bottom. So it comes out here. It's going to cool down a little bit. Okay. And then it's going to go back through this heat exchanger. Okay. So now the water loop from downstairs, it's getting heated up through this boiler. Okay. So now the water is going to come through here. Nice and warm. Okay. You see where the arrows are? Okay. But let's say I'm going to go here this time. It's going to go into this coil. And from this coil, okay, it's going to now go into my compressor.
Yeah.
Okay. And it's going to come back out super hot. So now my coil is super hot. So when the air comes in, it's going to go across a hot coil and heat up the space.
Oh, okay.
So it's getting the heat now from my boiler, which is called we're injecting heat into the line. Okay. Really, in this situation, you can kind of just turn off the cooling tower altogether.
Yep.
Okay. You no longer really need the if we have the boiler putting out the right amount of heat, okay, you don't want too much heat coming from this boiler. You're not looking for it to bring out 212 degrees, steam. We're looking for maybe, like 100, 120, somewhere in that range. That's going to heat up this water up to 85 degrees. Okay. So this comes in nice and hot. It warms up the what do you call it? The water. This water is going to go down warm. And as it goes down warm, it's going to go right into my compressor. My compressor is going to make it even hotter. And as the air comes across, it's going to blow across that hot coil. Make sense?
Yes.
Okay. So
Like
that's
I understand the flow now. I definitely understand the flow. I do need to get better on the wording, like for instance, the bottom where the water sat. The basin, yes.
Right.
And then I remember the bypasser where the fan and the valve is shut, so it enters straight into the cooling water tower.
Right.
And after that, and then and then the heat exchanger just it still goes past the heat. The heat exchanger takes it to the pump, and then the boiler is sending over that water into, I remember, to like 120,
Right.
80, 95, whatever the case, or whatever that number could be. And then and that water then, and the pump travels it into the air handler, into the coil, and then that coil sends the water into the compressor, and the water compresses I said the water, the refrigerant. That's because remember, I remember you saying the water and the refrigerant, it's all in the same, it's not in the same pipe, but it's sort of like in the
They have
same
like a
pipe.
pipe
Like
within a
there's
pipe.
separation. Yeah, there's separation between the two, when the water and the same pipe
So
going through the same flow.
can you see this cup?
Yes. Oh,
You see
yeah.
the straw inside the cup?
Yes.
But now imagine the straw was coming out on the other side.
Uh-huh.
So then the inside would never touch the inside of the straw, right?
Yeah.
Make sense?
Okay.
Just the way the
Yes.
straw is coming up top here. If the straw shot down on the bottom, it would never, the inside fluids would never touch the inside of the straw, right?
Yes, that's 100%. Yes, of
But if I
course.
got mad ice in the cup, whatever I have in the straw is going to cool down.
Yes. Yes.
Make sense?
Yes, it does.
So it's a pipe inside of another pipe,
Okay.
right? And
Mm-hmm.
that's what you're looking at when you look at this.
Okay.
Okay. You don't really got to understand the whole science of it right away.
Uh-huh.
You got time. You're gonna see this
Uh,
100 times. You're gonna see this 1,000 times in the field, and that's
mm,
when you're gonna be. So you walk up, you see like Florida heat, Bosch. You know you're walking up to a water source heat pump, and it's gonna say water to air, or it's gonna say water source or something. Okay,
mm,
which is gonna let
mm,
you know off the rip what is what it is. Okay,
mm-hmm.
so I'm gonna move along just because we're running late now. Okay.
Mm-hmm.
So we have an idea of how the unit works. Okay.
Mm,
So now if you look, it's going to give you like the sequence of operations. What are some potential things that could be happening? Okay.
mm,
Look, there could be scaling, corrosion. All of that we're talking about inside of that heat exchanger, the condenser. Okay. Inside of this tubing, wherever you got water going through, and you got water touching metal, shit's gonna get fucked up. Okay?
mm,
The water inside that metal is gonna start doing something called scaling. Like you ever see
mm,
like you'll see it over time. Like when you're making coffee, okay? Inside the strainer, you see some nastiness in there, right? So the nastiness
okay.
builds up. That adds up and
Mm,
as an insulator, meaning that there's no
uh,
heat transfer in between. So periodically we got to
mm,
do chemicals, we wash them out, pump them out, things like that. Okay.
uh,
Okay. Now, a way that you can also run these systems is look, you just got a hot water. Instead of having this whole system that we showed before, a hot water heater.
uh-huh.
Cold water goes in,
Uh-huh.
hot water comes back out,
Mm-hmm.
right? That's a whole nother way of doing it. Okay.
Mm,
So, but you guys got the idea of today's idea of the class really was this simple thing. You walked up to this unit. This is what the unit looks like in the field. Okay.
mm,
You didn't know how it works. So you looked up the nomenclature, you looked up the thing, the model number online, you found the PDF. Once you found the PDF, you were able to find everything step by step by step, what everything is. Okay, what's number two? That's my flex duct connection, right?
uh,
Okay, that's my supply air. This is my return air. Number six, right? It's going to tell you, okay, these are my hoses. This is, 11 is my pressure tank, my condensate drain lines, my ball valves. It's going to tell you everything that you should have. Okay, the cooling tower boiler system. The cooling tower and boiler water loop temperatures usually maintained between 50 degrees to 100 degrees to assure adequate cooling and heating. In the cooling mode, heat is rejected from the unit into the water loop. A cooling tower provides evaporative cooling to the loop water, thus maintaining a constant supply of temperature to the unit. Right? Okay.
Mm.
So these are, it's giving you everything that you need. Any questions with this? And it also gives you troubleshooting. Look, if you get one blink, it's your high pressure, two blinks, low pressure. Remember we went over that on the board?
Yeah.
Okay. All right. You go there, you got problem. The entire unit is not running. Possible causes. And you're gonna go through it. Power supply is off. What should you do in that situation? Apply power, close disconnect. You got a blown fuse, replace the fuse. Your voltage, thermostat. Make sure the thermostat is on the on position, and then you read through this whole thing, right? If it's in cooling, so if it's in cooling, what terminals on that heat pump got to be energized?
Um. let me see.
Oh,
Oh yeah, as the O again. Yes.
Right?
Suppressor
You got to energize the O, right? And what
valve.
else got to be energized?
The Y1 and Y2.
And one more, the fan.
Yeah.
So in cooling mode, you need compressor one, compressor two, you need the fan, and you need the reversing valve, right? And what do you
Yes.
need in heating?
You need Y1, Y2, and Y1. I mean, and W1 and W2.
Right. And also your fan.
mm-hmm.
Yes.
Y1, Y2, W1, W2. Very good. Because it's a heat pump, right? Okay. So I think we're done with this part of the class today, fellas. What do you think?
Yeah, it pretty much
There's a
covers
lot
everything.
of. I feel like I was never. I mean, every day I say I was able to. Like today, I had a lot of focus. Was not a lot of disruptions. I was really able to absorb a lot.
Man, listen, you learning. Don't beat up on yourself. It takes time, man. This ain't
Uh,
nobody, what's the old saying? They didn't build Rome in one night,
Yep, one
uh,
day, one billion a day.
right?
uh,
It takes time, man.
My
Right?
brother,
uh,
my brother Ron, I'm gonna let you know, Big Bro got like probably maybe a 1 year less than me in the field because I started
uh,
out as a helper, you know what I'm saying? But
uh,
none of this stuff I knew, bro. I didn't know none of this stuff, you know what I'm saying? I'm not talking about now, I'm talking about when I first started.
uh,
Even when I was in year
Yo,
4,
Oteni, stop lying. I think you got like 3 more years over me.
really? I don't know. I thought we was like somewhere
No, I'm at
beginning.
like 9.
Okay.
I'm reaching 9 in September.
Oh, so I'm year 11 like in the field, like in terms
Yeah, so
of
you got
from
me
when I
beat like two
started to
years.
now.
Yeah.
Yeah, 2 years.
damn,
So
bro,
yeah, that's
you
not
guys stop. That's a lot of experience, man. Just
no.
listening to
But you gotta understand, I was experiencing situations where I was being shut out of the troubleshooting aspect. So there was,
yo,
you know what I mean?
and I think
So
I was
and that's
going through
what
that.
that's where you at right now. So you basically this is your class where you're learning troubleshooting. I never got that. You know what I'm saying? I had to literally sat down in front of a unit like, yo, how does this work? You know what I'm saying?
Uh,
I wasn't using Google. I was literally scratching my brain trying to figure out how things work because I wanted to
uh,
learn. You know what I'm saying?
uh,
I
yeah.
never
So
had
Ron,
somebody that wanted to
use
teach.
Google. Use it.
Now we have Google. We could Google everything, bro.
Yo, Corey.
Uh,
Corey, you there? Because that's what's gonna happen to Corey. Especially once I'm out.
Hmm.
They're gonna put Corey with like a lot more like manual labor and all that kind of bullshit, right? You got a
uh,
lot of PMs and a lot of
Yeah,
bullshit.
yeah.
But what did Corey do? He calls us on Thursday or
Hmm.
Wednesday talking about, Yo, he's dissecting mini split.
Yeah. You're trying to figure out exactly how this thing operates.
So
So
instead,
he
like,
can
let's say you got a maintenance call, right? Ron, they call you on
Yeah.
some bullshit, change your belts and filters. And
perfect
now
time to
you
learn.
got 3 hours to sit down and relax and go on Netflix.
Okay.
Don't look around, get the nomenclature, read the manual, walk around the whole unit, figure out what's what and who's who,
Mm.
right? So
Yeah.
don't look, you're getting access to shit. You got a boiler. Go walk around, look at what it is, find the model number, look it up, look at the manual, read up on it,
Yeah.
right?
Uh-huh.
Google it, see what you can find.
We
So
we had we had a tech that just left the company named Mr. Wu. And I'm telling you this, Ron,
he was in
when I'm
class
working,
last week.
yeah, he was in class, right? And I'm telling you this, Ron, right now. When me and
Yes.
Mr. Wu go on when me and Mr. Wu go on a PM job, you know what I'm saying? He don't really like
Uh-huh.
PM jobs because it's a waste of his time, but nevertheless, he do it anyway. But when he goes
Uh-huh.
on a PM job and we finish working, doing whatever we got to do, you
Uh-huh.
will see this man walking around. Even though he's familiar with the unit, you'll see him walking around, pulling, taking stuff, trying to see what's what, how this, anything that he's not familiar with. You see him trying to take it apart and dissecting it and trying to learn and understand exactly how it works. You know what I'm saying? And watching him, that basically elevated me, make me as like, yo, that's how I gotta be when I have a little downtime. This is the perfect time to learn. You know what I'm saying?
Mhm.
Hey,
So when
he
you
would
have a
teach
little
us like,
downtime,
yo, don't be afraid of nothing.
yeah,
So like if there's BMS, study how the BMS works, right? Don't just sit there and be like, oh no, that's not our field, that's not what we do. No, we do that,
Uh,
right? We
hmm
do. So, look at the inputs, look at the outputs,
so, so not to cut you guys off. So that thing is real. So you could get really listen, man. I'm just like, yo, because I'm like, yo, because as I told you, when I was with these guys, okay, then you had to mechanically put it together. Me personally, after the first day, watching that, the next day doing it with somebody, and then the next week I got it. But you give me, there was a lot of extra stuff that they didn't know that I just naturally knew, just coming from school.
right?
You know what I'm saying? And then like for instance, the last big job I was part of, right? The last big job I was part of, we had to replace the compressor in the rack room. Um, okay, boom. We put the thing together. Like I'm not saying like we took the thing off, we put it together, and then when we had started it, it didn't work. So one thing I had noticed was is with the contactor and the compressor, the dude didn't understand brown, orange, yellow. You get me? Usually sometimes we're so used to seeing blue, black, red. You get me? I was telling the guy, wait, isn't the orange supposed to be on the outside? You get what I'm saying?
Wait, Ron, be careful with that though. So I hear where you're coming from with that, but
yeah.
always just check the phasing. Check which leg was which in 1, 2, and 3, and then in the disconnect box, and then match it back to the contactor. So,
Uh,
one is still 1, 2 is 2, and 3 is 3.
yeah,
And if
yep.
the compressor's
say,
not
say that
coming,
again. Say that again, big bro.
you want to make sure that all your phasing is right. So look at your screen.
Okay. Yes. Okay.
Okay.
Yes.
So it doesn't really matter which way they color coordinate it. Okay.
Mm,
You just got to know, okay, so blue is going to be my first phase, my black is going to be my
okay.
second phase, and red is going to be my third phase,
hmm
right?
hmm
Now, when it goes into the contactor, if you now have, red, black, blue, you might need to
Uh,
change these two legs.
and that's what I got them to do.
Right.
And then they were telling me that wasn't the reason why I started up. I guess it had something to do with the fuses that was inside the communication.
Man, they probably lied to you. It was
And I have
probably
a
as long
strong
as the
feeling
paper.
they did that. I have a strong feeling they did that because the guy looked at me and said, "Yo, Ron, you're right." And then the one Spanish dude that wasn't with the bull, like he didn't want to block me out.
Right.
Compared to everybody else. He was just like, yo, he looked at me. He's like, yo, what the hell? How did you know that?
So
Like you're a helper. Like, you know what I'm saying? Like, how did you know that? I'm just like, yo, like obviously if it's obvious. But
Frankie,
you
are
gave
you
it to
there?
me in better form. You know, because it obviously starts from the first stage, which
Wait,
is gonna be the
Frankie, are you in here? Look, I'm gonna stop sharing for a second, right?
you
I'm
good?
I'm gonna stop recording.